Hi, good morning, everyone. Thanks for coming today. I'm Thang from Google Australia. I'm a network SRE. I have been there for about 4.5 years. So today I will give you a introduction about Google SRE and how we implement that. So let's start. Can you tell me, please, just raise your hand if you want to answer me, what you worry about most about reliability? Just raise your hand and have it. That's a quick question. Probably, okay. Yes, so tell me.
I think it's about network reliability.
Network reliability.
Yes.
Okay. Any other questions? Sorry, any other answers? So to me, the most thing that I worry about is that when I deploy a service to production, it may not work as I planned. It may not work as I tested on the staging. So today, I will give you a talk about how we deal with that at Google. The talk today will be we have 4 sessions. The first thing I will talk about how about what is the core problem that SRE solve, and the next thing is that the main principle of reliability, and the next thing I will tell you about 5 practices that SRE is using, and in the last 2 sessions I will guide you how to start, how to adopt the SRE model. So let's start. So the first thing I want to talk about is what is SRE, and it's very normal that in my experience, companies normally focuses more on designing and building an application or a service, but they don't really look into the operation. And we did there are some studies showing that about 40 to 70% of the cost involved after the launch related to operation. So the cost of operation is relatively high. And if you have any problem with the service after you launch, you have to spend a lot of money. The product may be very fancy, but it could not a good product if it doesn't work, right? So there are normally battles, or many battles, ending battle between developers and operators. Developers want to deploy a service as quick, as fast as possible. And they just want to release new feature, they want to release new product, and they throw the product away over the world to operators. On the other hand, operators want to slow down everything as much as possible because they want to slow it to reduce the risk of a problem that may arise. And so that we have some approach to solve the problem to some extent. During the business planning and the development, I will solve some sort of this. And then DevOps come up to solve the tension between development and the operations. What DevOps does, actually, they try to break the silos between development team, business team, and the operation team. So there are many definitions of DevOps, and and here's my definition. It says, DevOps is a set of practice, a guideline to break down the silos between IT departments within an organization. And DevOps have 5 key areas. The first thing is that it reduce or to break down the silos between different teams in an organization, try to increase the velocity of product development and release. And DevOps accept the failure, and they will plan for that. So say, hey, yeah, we know something will break up, and we plan for that, so we don't panic. And DevOps also lies with development team to release smaller and smaller changes than a big change, because smaller change will be easier to control the quality, easier to roll back if something wrong, and so on. And also, DevOps to some extent don't want to repeat the job, don't want to repeat a task, don't want to repeat a script every day. So they want to get rid of human error from the process. They want to automate everything, and they use tools to do that. And the last thing is that we will not know if something breaking or something successful if we don't have a monitoring system. So DevOps, to some extent, they measure everything. And then how SREs is similar to DevOps. SREs actually is an implementation of DevOps. And SREs use data to guide the decision making. So they use data to see whether you want to make a decision to, say, deploy a feature or roll back a feature. And SRE treat operations as a software engineering problem. So we will, oh, something happening, it's not reliable. I think the cable is not reliable. Give me a second. Okay, someone take over from me, I think. All right, okay, thank you. So let's come back. So how do we treat operation as like a software engineering problem? We use people with a very high motivation to use software to solve the problem. The second thing is that we use software, we use automation to perform all the tasks, daily tasks. And lastly, we involve to the design of a software, of an application, of a service from beginning. So we don't want to say like, okay, someone writes everything finished and then throw it to SRE. We involve from the beginning. And then what do SRE do? What do SRE team do? In a nutshell, I can say that SRE is a group of people. SRE is a set of philosophies, and SRE is also a job role. What else is that? We involve, we build, we run a very large-scale system in a reliable way, in an efficient way, and in a scalability way. And also, we know that we always hope for the best, but we always also plan for the worst. So we always have a plan B or C or D. So this is a thing, that's a very interesting thing. People will always think that, okay, DevOps, SRE, are they similar? Are they different? And so on. So to me, like I mentioned earlier, SRE is an implementation of DevOps. And so, in a nutshell, SRE is a set of those practices that we have to work, that implement DevOps, and it's a job role. Remember that SRE is a job role as well, not only a title. And at SRE, how do we deal with the reliability? We have only one biggest principle, is error budget. We use error budget to control everything. So let's see how we measure error budget and how we measure reliability. So let's first start with measuring reliability. The name is the most simple way is that we measure something by good time divided by total time, and then say, let's say we have server up and server down, something like that. So this method is very simple, very easy to understand for people, for human. However, it has a lot of drawbacks. For example, it's hard, very hard to represent some distributed or some complicated services. For example, how do you tell if a server is not is good or bad if with some request is accept, but however from the other request is reject? Or you say you have a service with 10 servers, and then 5 of them are down. Do you think the service is up or down? And then, so as with SRE, we come up with a more sophisticated approach. We use interaction, and then we use good interaction over the total interactions. So with these interactions, we solve those cases or more complicated cases. For example, like the server request up or down, or how many servers are down in a total server farm. And the error budget is all about the total number of minutes downtime that you are willing to tolerate. For example, when I say 90%, when I say 90% reliable, it means that in a year you can expect 36.5 days downtime, or probably in a 30 days you can expect 3 days, and so on. So in this graph, you can see that you have 90%, we have 95, up to say 90.999%, which means like 1 night, 2 nights, 3 nights, 4 nights, 5 nights, something like that. You may wonder that there's something missing here, but something very important. There's no 100% here, right? We don't have 100% of reliability here. Why is that? Because according to Thang, the founder of SRE model, basically 100% is a wrong reliability target for everything. We can't achieve 100%. We have to expect that. And then, so how do we accept that we don't have 100% of reliability? So that we need to pick something that meets the needs of our users, not something that the number is saying. And people are going to notice things that being down or not, or some set of people being notice that something is down and other people notice that something is up. This is something that we need to work out with not only 1 people, 2 people, 1 team or 2 teams. We need to get the whole organization to agree on this. For example, the product manager will know that the user will expect this service to say 95% reliable, or as I say, no, with our current infrastructure, we can only afford 90%. So this is something mutual agreements between different teams in an organization. And then we put user first. We try to get a highest reliable as possible. And so what are the benefits of error budgets? We have a few, actually. This is a very powerful tool, powerful indication that you have a objective way to say to measure the reliability and whether you are meeting the target or not. You are making people happy or not. You are making your client happy or not. So we can go through the few of the benefits I listed here. That is, the first thing is that we have a measurement for dev team and SRE team to agree on. The way it works is that we say, hey, dev team, you have 4 nights of reliability, which means that you have, say, a couple of minutes downtime a day. You can spend that. And once you spend all of the error budget, then you need to work on reliable. You need to make your product more reliable. You need to say, stop releasing new feature, but fixing the bug. So in order to measure something, we need to have some measurement, some indication, and so on. So we start with SLI, service level indicator. What is SLI? It means it's a well-defined measure of successfully enough. For example, you may define that the server is up or down by, say, you try to ping it, and then you don't get a response, say, 50% of the response are down. However, you have a more complicated SLI, say, the total, the percentage, or 90 percentiles of requests that have 5 meg of user data returned, and the request coming from a reason, specific reason, toward a specific other reasons, and so on. So you can have a very complicated SRE, or you can may have a very simple one. It's totally up to you to define. And then with the SRE, we will establish SLO, service level objective, which means it's a target. So I want to have a full SRE with 95% target, which means a SLO. And what happens if we violate that? Then we have SLA, service level agreement, which means that when you violate the SLO, you will need to, say, refund some money to the customer, or you get a fine or from them, or so on. So this is an agreement between you and your clients. And your client may not be an external one, but maybe an internal team as well. It totally depends on the product. So with the SLO, we try to exceed the target, but we will not go beyond that. We will not try to go beyond that. Say, let's say if you define 90%, 90% is just enough, right? And like I mentioned earlier, define a SRE is complicated, and so on a SLO. So my suggestion is that you try to start with something simple first, and then polish it later on by the time. So the more time you use it, you will say, okay, we need to tweak it a bit. So start with something simple, and then polish it later. So with SLO and error budget, we have covered 3 main areas of DevOps: the business to development and the development to operations. And in the next session, I will tell you about 5 key practices that we implement as SRE. There are metrics monitoring, capacity planning, change management, emergency response, and the culture of SRE. So let's start with monitoring and alerting. We will not know that something is happening according to our plan if we don't have a monitoring system, right? So you need to set up a monitoring to see how good the system is. And then we need to set up some threshold. Say when something breaks enough, then you need to alert people, alert human. But you don't want to set the threshold too low, because it will be very noisy for the operators. So you need to find a balance. Say when something breaks enough, then you will alert human. In the next practice that SRE also looking at is the planning, capacity planning. The capacity planning involved either plan for organic growth, means that the service is very good, and then people keep coming and people keep using it. So you have, say, 50% more user every year, so it's some organic growth. You need to plan for that. So like you have some plan accordingly. We will also have some inorganic growth. So for example, when you release some feature very fancy, people love that. Say, well, using this app, I find a new girlfriend, boyfriend immediately in 2 days. Then people start jumping using that, and then boom, your total user, active user just jump. And then so before you release new features, you also need to sit down with your product manager to plan for that as well. And the last thing is that we have some raw resource, for example, the machine, but we haven't provisioning it yet. We need to also plan for that as well, because buying new infrastructure or deploying new infrastructure are very expensive. And if you don't plan accordingly, leave it to last minute, it will be very costly. So in order to do planning and capacity planning in an efficient way and in a high performance way, I would suggest you, or SRE, to optimize utilization. For example, if in your code you use too much memory, or you don't have a garbage collection, and then it leads to some memory leaking, then try to optimize the code, and then in a summary way, the total memory that you use may reduce, or to say find a better algorithm to reduce the cycle of CPU, and then so on. You will not need too much CPU. It will save a lot of resource. And also, as a SRE team, you need to always monitor the utilization, always monitoring it. So you will see, you will find, you will detect some abnormal utilization and see what's going wrong, why it's happening, and how do we fix that. Right? In the next practice, I want to talk about is the chain management. So SRE will involve heavily on a chain process. And at Google, we conducted a internal investigation. We found out that about 70% of outages are due to some recent change. It's a very shocking number, right? Whenever you release a feature, there will be something introduced, a bug will be introduced, there will be some weird behavior will be introduced, or some regression bug come back. So with roughly 70% of outage, then you need to have a very good chain management to avoid that. So how we do that? We use progressive rollout, which means you try to break down the rollout to smaller parts. You start with a testing instance, you start with a small region, and then you say divide the global rollout to say 4 days. So each day you will roll out to some certain regions. You don't roll out everything at once. And we also need to have a very good monitoring system to quickly detect if something happening, something wrong, why the rollout is happening. So we can break, we can pause, we can freeze the chain immediately, and then work on the mitigation. And also, the last thing very important is that you will when you come up with a change plan, you always have to have a rollback plan as well. The rollback needs to be very easy to run. It needs to be very simple to run, and it will just roll back everything to the last known healthy state. And we will not achieve this thing if we still have human. We still have used human heavily in the progress. Because why? Humans always have error. Say, today you're tired, today you're sleepy because you're watching football yesterday, or you break up with your girlfriend, boyfriends, so you have some, not really clear on or in a good state. So we need to get human out of the loop, out of the progress. So we will talk about the implementation of getting human error out of the loop in the next sessions. I just want to remind again with the 100% is the wrong reliability target for basically everything, which means that we need to determine the desired reliability for the product, and that don't try to provide something better than that, better than what you have committed. And in addition, at a development team, you can spend a budget to increase the development velocity. Say, you know that something is breaking, but you're breaking under control. You're breaking under a budget. So you still can keep developing things. And only once you reach the threshold, then someone will stop you. Until then, do not stop. Even you know something is breaking, something is on fire, just keep doing, just keep developing the new feature so that you still keep the velocity going on. So come back to the capacity planning. We will in a daily job of SRE, somehow you need to provisioning new infrastructure to the system, to your service. You convert from raw resource to something that you can use for your service. Then how do we do that in an efficient way and a safe way? Well, this is a combination of change management and capacity planning, because it's actually when you introduce something to the system, the new introduced or new added resource may not work well with your current system. So you still have to have it under a change management control. And it needs to be done quickly, right? Because if it's not quick enough, then your service will be, running out of resource, and then you may not serve customer well. And also, you need to use automation to do it, because, try to automate it will get rid of human error, right? And this is the thing that I always find it interested in my life, the emergency response. So what would you do if something's on fire? You receive a call from on a high level manager saying, hey, the service is totally down. So you will feel panic, you will feel nervous, and you will think, what did I do wrong, right? It's very heart-beating moment. Oh, wow. Everything's on fire, and I will be fired next day. Well, try to not be panicked, right? This is the first thing. This is a very important thing. Try to not be panicked. And you are not alone. The sky is not yet falling. You have people around you. You are smart. You will know how to handle that, right? And this is important as well. After you calm down, don't try to fix the problem. Try to mitigate it first. What is the difference between mitigation and fixing something? This is the thing. Mitigate something means that you try to avoid something bleeding. For example, if the service is not not accept new requests, however, it still serves some certain requests, then try to contain it, and so that you can increase. This can serve the old customers. Once you mitigate the problem, then now it's time you come back to fix it or find the root cause. But do not do it when you are in an emergency mode. And importantly, that you are not alone. You have the team surrounding around you. So if you feel something overwhelming, if you feel something that you cannot handle yourself, or if you keep receiving pings, messages, call from other people saying, hey, what's going on? When you will fix it? How did you fix it? Tell me. Otherwise, customers are angry, and then you will be in trouble, right? So you need to deal with technical issues. You need to deal with communication issues. That's the time you need to pull people in to help you. And I'm certain that people around you will be happy to help you according to a plan. So when you deal with a incident or emergency issue, it's very important to well predefine a threshold when you would declare it as an incident. For example, if you have a service for serving 1 million users, and just 100 people complaining that the service is down, then it might not be the service, but maybe just their internet service having a problem, right? So try to not be panicked too early. You need to define a threshold when to declare an emergency incident, and that's important because if you define it too low, it will be too noisy. If you define too high, then the service is now in a damaged state enough that you don't know, you are not aware about. That's also bad, right? So it's very important again to define incident and the criteria before something happens. All right. So once you done with the mitigation and you find the root cause, what else do you need to do? You will not stop from that. Okay, I'm done. No, you need to make sure that it will not happen again. That's important, right? You need to make sure that you truly understand the problem, and the whole team also understand the problem, and you learn from that mistake by writing a postmortem. Postmortem is a document that to state all the state of the incident. For example, the timeline of the problem, how do we take it, what are the impacts, and how do we roll back, how do we mitigate, and how do we make sure that it will not happen again. And the postmortem is well expected after any major incident, so that again we'll make sure it will not happen again. So that's it. And in a postmortem, a very important culture, a very actually interesting culture is that don't blame the engineer that did it. Why do we not blame them? So it's very normal that in Google Postmortem, we will not name anyone. We just say engineer, an engineer, or so on. So why is that? Because the postmortem is focusing on the incident itself and how do we prevent it from happening again. It's not to blame someone to probably that reduce the salary or fire him or her. It's not important. And if human involved into the problem, which means that your system have a flaws, it's actually a system problem, not a human problem. Because your system is not well automated enough that a human can break it. So rather than blaming someone, you need to fix the system problem. And the culture of, if you keep blaming people, then you will not, you will scare them. Then you will not say next time if something happens, no one will try to stand up and then say, okay, this is my problem, and then here how I did it, and then how we can avoid it. You will not learn everything from bottom up if people are scared and people, are punished. So important that no blame, no punishment. So we talk a lot about automation, about trying to automate everything, every task, every daily job. However, we as a SRE still ask engineer to do some toy or operational jobs. Why don't we automate that? Basically because we can't automate everything. And normally we try to automate if something happens again at the second time. For the first time, you don't know what it is, right? So you can't automate it. You can't forecast everything and then automate everything that you may not need it. So you need to involve in the operational job. For example, run a script to deploy a server or so on, so that you feel the pain of doing manual job. Once you feel the pain, you have more motivation to automate it. That's very, very, very important. All right, and so how do we structure a SRE team? And say, do we need to find fancy people, or what kind of people we are looking to hire for a SRE team? So we try a lot of approaches, and then we have found out that a typical mix of 50-50 of SRE, software engineer, and SE, system engineer, are the best combination. However, everyone needs to know how to code to some extent. So why do we need to get a mix of SRE and SE? Because SRE is a thing that we use software to treat the operational system problem. Which means that everyone needs to know how to write software. Everyone knows how a software runs. Everyone needs to know how to design a software from scratch. So we found that SE, actually the system engineer, is not ops work, but also coding work. You do code a lot as well. And SRE will not be efficient if what they say is not honored by other team. Say, when a dev team uses up all the error budget and then SRE say, hey, you have spent all of your error budget. It's now time to look at reliability. Stop releasing new feature. And then they don't listen to them, right? So it's very important, it's crucial to empower SRE. And this needs to be done from very high level of management. Say, listen to SRE. If SRE say no, means no. It means do not deploy any more feature, but fixing stuff. So let me recap the 5 practices that I just that mentioned. The metrics monitoring means you need to keep monitoring, define and monitoring SRE and SRO. You have a dashboard that dev or other people can just look at and quickly and very simple to say, okay, something is going on or something's on fire. You need to do capacity planning, which means you need to do forecasting, you need to do provisioning. You need to have a well-prefined change management process to avoid something breaking, to avoid a global outage. You also need to have a emergency response procedure, and you need to train people to be familiar with the process. So when something happens, something on fire, they're not panic. They know what to do. They know when to pull people in. And then also when they write a postmortem, it will be valuable to the team and not to just blame the people that causing the problem. And lastly, we talk about the culture. We mean we need to do the toy work so that the engineer will feel the pain and then motivate them to automate the job and so on. So just to have a quick summary, we have covered all 5 key areas of DevOps. With combining SRO, error budget, and the practices that I just mentioned, we cover all the 5 of them: the share ownership, the error budget, a blameless culture, reduce the cost of failure, we automate common cases, and we measure toil and reliability by monitoring. So, how do we start? If you feel that something suits you, or something that the organization needs to implement, then how do you start? So here's my recommendation. This is how I would suggest you. Let's start with SRO. Start with something simple. Start with something small. And then you try to get people, engineers, that know how to write or how to code, and then ask them to work on the dev team, a operational team. And also, you need to ensure the priority of respect to SRE. You need to give them the power. They need to have their voice. They can tell other people, other team, when to stop, when to start something. And also, you need to give them some feedback loop. They need to be able to decide what they want to work on. If they want to work on a automation this task, then let them do it. Because they already feel the pain, they know what to do, and they are willing to do it. That's great, right? And to start with, you can do this. Let's pick a service in your company, in the organization, to run against the SRE model. You need to pick a high-level manager to give the SRE team or to give the operational team to have some power. And also, the culture, the safety are very important, are very critical, right? You also need to measure the SRO. You need to measure the service health. And lastly, that you try to you try to have a progressive rollout to do not try to run out everything globally, everything at once. So let's start with something simple first, like all of those bullet points. And once you're successful with that dog food or that experimental project, then it's now time for you to spread the love to everyone, to every other team in your organization. So you will expand it to more services. And I'm sure that you will be loved for that. And also, if you have a well-defined SRO, well-defined process, we as Google will be very happy to help you, to work with you, to reduce to relieve the pains that you are experiencing. And so now, in order to start with cloud, which is a very hot topic, right? You can see that we believe that at Google we believe that SRE is a reliable, efficient way and reliable way to solve the cloud reliability problem, right? That the scale will not meet the operational demands, the automation, engineering, enable scaling system without scaling the whole organization and so on. And the error budget is very powerful to measure, to help you measure the reliability, and also to make sure that the development velocity are maintained and so on. And we also have books to help you with SRE adoption. We have 3 books so far, and the good thing is that you can read it online for free. You can go to www.google.com/SRE to understand more, to find the link to the books as well.